So everyone is talking about build.
Hello, and welcome to Microsoft Build Digital 2020. I'm Donna Sarkar.
And I'm Seth Juarez.
Maybe I should pick my top 10 releases from Build. Of course, only talking about AI and MR, which is my main field. You know, I like to keep it simple. So, some exciting announcements were made at Build and MR Dev Day. I will cover today the ones that caught my attention. Let's start with number 10, containers. Customers can deploy cognitive services anywhere, from the cloud to the edge. Language understanding and text analysis are now generally available in containers.
AI org, which really is all about pre-built machine learning models and making them accessible to you in the form of services, web services, SDKs, and now containers. So now we leverage Docker containers in order to deploy this technology so that you can use this where you need it. Often we refer to this as the intelligent edge, right? Edge computing is all about, having wherever your data is, putting the compute or the processing as close to that data as possible, as opposed to having to travel the network in order to do any of that work and any of that processing.
Number 9, new optimization techniques built for Turing model. Now available for OwnNX runtime. Microsoft is announcing that some of the key optimization techniques built for training the Turing model, the largest model in the world, will be available as part of OwnNX runtime in June 2020, allowing organizations to reduce cost and deliver ML innovations faster.
This is our Turing NLG demo site, and the way this model was trained is you give it a piece of text and it's trying to predict the rest of the text. So you can give it, half a sentence and it finishes the sentence for you, or you can give it a couple sentences and then it, finishes a paragraph, or it tells a story, and so on. So we're going to try some open-ended things and see how it does. The first is I will start with something like today Kevin Scott announced Microsoft's partnership with OpenAI, and then we'll hit generate and just see what this model says. And you can see this model actually is very fluent. It's grammatically correct. You can see it also has some knowledge relationships, like it's starting to mention Jan LeCun, who's a deep learning expert. It talks a little bit about folks who work in OpenAI, and you'll notice that nowhere in this prompt did I talk about who works at OpenAI. And this model isn't going out to the web and copying and pasting sentences. This is all knowledge that's actually ingrained into the model just from reading tons and tons of text.
Number 8, this is one of my favorites. Azure Special Anchors out of preview. Now generally available for mixed reality developers. Azure Special Anchors, which enables developers to create mixed reality apps that map, persist, and share 3D content at real-world scale, is now generally available. You can find some tutorials on how to work with ASA in my blog.
So one of the fundamental challenges in mixed reality is how to keep your digital content locked to the same physical world location over the course of time. This is called persistence. And another one of the fundamental challenges is how to then share that digital content in that exact physical world location with the others around you. This is called sharing. Now, persistence and sharing are pretty basic, normal concepts in life that we just take for granted. Say I was working on a jigsaw puzzle over there on my coffee table. When I come back the next day, I would expect it to be in pretty much the same state, or else I'd wonder who helped me out and completed my puzzle for me or moved it, right? And that's persistence. Now, say that my husband walked in the room and I wanted help with that jigsaw puzzle. Well, he would immediately see it. We would work together. It would just be there. It'd be natural. And that's sharing. And these concepts that are simple in real life, in our real world, are actually a little bit complex in the digital world. So Azure Spatial Anchors exists to help developers with exactly these concepts in the digital world, sharing and persistence.
Number 7, Azure Remote Rendering. A game-changing Azure Remote service recently made available in public preview. Azure Remote Rendering lets enterprise developers in industries such as manufacturing, engineering, construction, and retail bring the highest quality 3D content and interactive experiences to mixed reality devices such as HoloLens 2. This service uses computing power of Azure to render even the most complex models in the cloud. It streams them in real time to your devices, so users can interact and collaborate with 3D content in amazing detail.
Hello, my name is Christopher Mantai, and I'll be demonstrating the Azure Remote Rendering Showcase app. As the name suggests, it demonstrates various features of Azure Remote Rendering. It is built in Unity using MRTK. Let's start by loading a model. For example, we can load the engine model that is built in and is mostly used for demonstration purposes. There we go. Now that the engine is loaded, we might want to know if the engine is assembled correctly, so we would like to take a peek inside. One way to do that would be to move all the individual pieces to have a look inside of the engine. As that might take a while. Alternatively, we can programmatically move all the pieces to explode the engine. This also gives us a nice opportunity to show that locally rendered content like this menu and remote rendered content like this piece of here nicely composite into the same frame. Now, it would take me quite a while to reassemble the engine one piece at a time. So alternatively, I can just revert what we did and start from the original state of the engine. An alternative way to look inside the engine would be to take a cut plane and slice through the model. This allows us to take a look inside of the engine without actually taking apart the engine piece by piece. Now that we've loaded the engine, we may want to load another model so we have a car that we can place our engine into. So let's do that and load another model. This car is pretty big, so let's scale it down so it actually fits into my little room here. There we go. Now the car's a little bit dark, so what we could do is we could recolor the car with a brighter paint. Like this, for example. Or alternatively, what we can also do is just load a different environment that is generally brighter, like this one. Now that we've loaded our car, let's take off this piece and place our engine into it. Now the engine doesn't quite fit. So luckily Azure Remote Rendering allows us to transform any remote object as you would expect from a locally rendered object. So let's just scale it down a little bit, rotate it a bit, and place it inside of our engine. Close enough. Let's put the cover back on our car, and I'm not a car mechanic, but I think this is good enough for a demonstration. Thank you very much for watching. Bye.
Number 6. StairKit MR made easy. StereoKit is an easy-to-use open-source mixed reality library for building HoloLens and VR applications with C# and OpenXR. StereoKit prioritizes mixed reality applications development above all else, allowing for features such as first-class mixed reality input system, fast performance by default, even on mobile devices, quick iteration time on device, and a runtime asset pipeline that lets users and developers load real assets from the file system.
What is StereoKit? StereoKit is a mixed reality library built on C#, OpenXR, and Visual Studio. It's open source and it's designed to be really easily used. So this is kind of a collection of tools that allow you to build mixed reality applications. Things that are kind of tough to do from scratch. Things like stereo rendering, physics, user interface, 3D asset pipelines. These are all really tough problems to do, and usually you have to go to a game engine in order to get them. So the whole goal of StereoKit is to make all of this stuff accessible from an environment that's more comfortable to a lot of the developers, or is even a little bit better for people who don't necessarily need to make an entire game. So as you can see, these are features from the latest highlight reel that I published. Version 0.2 just came out a little while ago. So this is something I'm super excited about.
Number 5. This is one of my favorites also. Project Moab. A new open source balancing robot to help engineers and developers learn how to build real-world autonomous control systems. Customers can 3D print the robot. We are talking about a new hardware kit that is available as a simulator in MathWorks and soon a physical kit for 3D printers. It's a 3-armed robot with a joystick controller that attempts to keep a ball balanced on a magnet-attached transparent plate. Availability for purchase will be announced later this year.
To help you get started on this journey, we have, in conjunction with our growing ecosystem of partners, created Project Moab, an open source machine teaching robotics hardware kit which allows you to quickly learn via a fun desktop balancing platform. It can quickly go from the seemingly straightforward, but in actuality decidedly non-trivial, to the exceedingly complex, all while enabling you to learn how to harness sophisticated simulation and machine teaching capabilities for your own use cases. The Microsoft Autonomous Systems platform allows you to drive real-world innovation, build trustworthy autonomy, and scale human expertise.
Project Bonsai. Project Bonsai, a new artificial intelligence development platform for developing autonomous industrial control systems. This AI platform can be used to make factories more efficient.
Project Bonsai is a new service from Microsoft that enables engineers, subject matter experts, and others who are interested to teach an AI to solve complex dynamic control problems. At its heart, this new technology uses something called machine teaching. Machine teaching is a new way to express what it is you want an AI to learn and how you want to learn it. One of the core components in this new technology is a reliance on simulation. With simulation, the AI can learn from lots and lots of data before we go and put it onto a real system.
Number 3, we are getting closer to number 1. Unreal plus MRTK for HoloLens 2. Unreal Engine is one of the most widely used game development platforms in the world. It now offers production-ready support for HoloLens 2, including Microsoft Spatial Audio, app remoting, mixed reality capture, and beta support for Azure Spatial Anchors. And the best thing is, Unreal Engine is free for developers.
So some of you may be wondering, what can Unreal Engine do? What's all this hype about? So I think this video is an excellent illustration of the rendering capabilities of Unreal Engine, what people love about it. So this is a demo that was built by Epic Games to commemorate the 50th anniversary of the Apollo mission. So this is, what you're seeing here is 7 million polygons streaming from a desktop PC to a HoloLens 2. It's in a physically based rendering environment, fully dynamic lighting and shadows. That Saturn V Saturn V rocket that you saw come up, that has 84K textures on it. Like the photorealistic quality of of this demo is truly incredible and really never seen before on a mobile device. So this is something that's open source. You can go today to the Unreal Engine docs website and download your own copy of this, get a copy of the assets, and take a look at how this was built.
Number 2, building immersive MR experiences with Babylon.js and WebXR. Another exciting feature addition for HoloLens 2, this was also announced last week, is the support for web-based spatial computing WebXR applications, powered by the Firefox Reality Browser and Babylon.js 3D engine. Number 1, I think we all know which one is my number 1, the supercomputer. This is my number 1. Microsoft built one of the top 5 publicly disclosed supercomputers in the world, making new infrastructure available in Azure to train extremely large artificial intelligence models. Hosted on Microsoft Azure Public Cloud and built with and for OpenAI. I think a supercomputer in Azure makes perfect sense. We are soon going to see a lot of more practical use cases. We can only guess at what OpenAI will be able to develop with one of the world's fastest supercomputers.
AI supercomputers and these gigantic models that we've been working on, and in a very real sense, like you all are at the very, very frontier. Like you are doing the most ambitious work in AI today. Yeah, and so I know you've got a demo to show us today, so I'm going to be tremendously exciting. Like I think this might be the first time that I'm seeing this. So this is an application of what these really, really big models can do.
And so we use the Microsoft supercomputer, our generative text models, and we fine-tuned it on thousands of open source GitHub repositories. And we'll roll the video and show you what happened.
I'm going to show what an OpenAI language model can do when applied to code generation. The model I'm using today was trained on code from thousands of open source GitHub repositories, using the same unsupervised techniques as our GPT models. Let's try it out. I'll start with a pretty basic Python task. I want to write a function to check whether or not a string is a palindrome. I'll start by writing the function signature and a quick comment string. And now I'll ask the model to generate the code that it thinks should come next. Great, the model got it right. But that was a pretty simple example. If I searched for is palindrome on Stack Overflow, I'm sure I'd find something similar. So let's step it up a bit. This time, I'll write a function that definitely wasn't in the training set. Let's return list indices for elements that are palindromes. And at least 7 characters. And let's see what code the model generates. Great, that looks right. And it even used the isPalindrome function from above. This time we can also rest assured that it didn't just copy some snippet from the training set. The model came up with a unique solution to a unique requirement. Let's step it up again. This time, I'll write an order class composed of items. I pasted in some code defining the item class and the properties of my order class. Now let's write some methods for the order class. Let's start by writing a method to compute the total price. But let's add a twist. Let's apply a discount to items that are palindromes. Let's see what the model suggests. It helpfully writes a comment string for us. But that's not quite right. I only wanted the discount applied to palindromes, not to the whole order. Let's edit the comment to clarify what I wanted. Compute the total price and return it. Apply a discount to items whose names are palindromes. Let's try again. So far, so good. Great, that's much better. Actually, I wanted the default discount to be 20% off, not 80% off, but that's an easy enough fix. There we go. Let's round it out by printing a receipt for the order. Print the total price and the price of each item. Here we go. Perfect. That's just what we wanted, and it even used the compute total price method that the model and I wrote together. Beyond helping implement functions, we've also seen the model excel at other development tasks, like writing unit tests. All in all, this model can generate useful and context-aware code suggestions that would make any developer more productive.
Build 2020 conference was one of the best online virtual events I have attended so far. I also enjoyed Mixed Reality Dev Days, which was hosted in a virtual reality environment in Altspace VR platform, which made attendance much more immersive, and as usual, a pleasure to share with the MRTK team. Jesse, you know it. Hope you enjoyed this short kind of news video. If you have a special computing project in mind or any artificial intelligence idea you would like to implement, please, I would love to hear about it. So reach me out to my mail or any social media. Thanks for watching.